Hey there. So we're given a question or a problem here. So the problem is basically an object is being launched at 40 meters per second at 50 degrees relative to the ground on the cliff. So the cliff is 36 meters tall. That's how high it is. So we're given a typical question. You can read it from A to E. The question A asks, how long is the object traveling in the air? So how long will the object be? Will be basically in the air, and how far as in like horizontally, how will it be displaced from the base of the cliff, and what is the height that object will reach, and what time does this occur, and etc. We have all the way from A to E question. Okay, so we're gonna go through each of them. So typically these type of questions usually, or problems, you have to break into two components: a vertical and horizontal component. So in the vertical component, you have to use the equation that involves displacement slash distance, with acceleration, time, and velocity. So okay, so what is it that we already know about the vertical component? Okay, so we know that gravity is a constant, negative 9.8 meters per second squared, and then we're given a velocity of 40 sine 50 degrees meters per second. That's the vertical velocity as it's being launched up towards upwards, and then we're given a vertical displacement at negative 36. So negative 36 indicates that the object will ultimately it's going to reach the base of the cliff, which is about 36 meters downwards. So when they plug all of that into the equation, and you'll get something that looks similar to a quadratic equation. And then on the horizontal component, it's rather very linear. You can see a velocity multiplied by time. The horizontal velocity is 40 cos 50 degrees, and then just plug that in. Now, in order to get time, you have to solve the vertical component. So essentially just solve the vertical component for the time value, and we know that it's essentially a quadratic equation, and so we just have to use a quadratic formula here, just as we see here. So when you do these quadratic equations, in one of the answers usually a negative, the other one's positive. Obviously the time value is supposed to be positive, so we're going to of course use the positive value. So in this case, the positive value came out as 7.265 seconds. So now we're also asked to solve the horizontal component, for the horizontal displacement, the horizontal distance it has traveled. So we already know the horizontal velocity. We just have to plug in the time in order to multiply velocity with time in order to get distance. So, and once we do that, it came out as 186.79 meters. Alright, so far this is how it's solved. So far we have the total amount of time that this object has traveled, and along with the horizontal displacement distance it has traveled. Okay, so that's so far that's the case. Now we have to find the maximum height the object reaches. Now in this case, the equation here is the one that shows one with the time is not involved. So v final square equals to v initial square plus 2 multiplied by acceleration by distance. So we have that. The thing is, like, when an object reaches the maximum height, the velocity at that point is really momentarily zero, just at that second. So knowing this, we can set the velocity final equals 0. So once we do that, the only unknown variable here would be the distance, the height basically the object reaches. So just plug it in, manipulate it around, and then eventually we get the value of the distance, which is the height, which is 47.9 meters. But one of the things you have to understand, like when an object is being launched from a cliff or from already like certain height, there's basically two heights, so there's a maximum height that is relative to the bottom of the cliff, and there's also the one at the top of the cliff. Now if you're looking from the bottom, the base of the cliff to the maximum height, then you have to add in the 36 meter, so which gives you 83.9 meters. Alright, so now when does this occur? When does the object reach the maximum height? At what time? Okay, so in this case, we can just go ahead and use this equation where velocity final equals to velocity initial plus gravity times multiplied by time. So we already know the initial velocity of the vertical component. We know the gravity, and time is the only thing that's there, so we have to find time. And once we manipulate it around, we get what time it is. And okay, so now we have to determine the final velocity. So in order to do that, we have to have both the horizontal and the vertical velocity. And horizontal velocity overall, it stays the constant, it stays same throughout the entire motion. Vertical, however, is the component, it goes through a bit of change. It goes through change, and mainly due to gravity. So I mean, the horizontal velocity component, we almost don't have to worry too much about it. But the vertical, we have to take in the gravity into consideration. Okay, so we know what the gravity is, we know the overall total time, and then we know the initial vertical velocity. So it gives you, negative 40.555 meters per second, indicating it's going downwards. So, and we have to just use this as one of the components. Okay, so plug it in, everything. The final velocity, the magnitude at least, comes out as 48.02 meters per second, and now we have to find the direction, and we have to use 10 theta. And when we do that, it comes out as, the theta comes out as 57.63 degrees, and the final velocity turns out as 48.02 meters per second, right to the right side, 57.63 degrees downwards. All right. Now, the final question, the question E, it asks, what is the velocity of the object 2 seconds before it hits the ground? So, in this case, it's very similar to the question where it asks about the final velocity. So you just use the same equation, and instead of the time it traveled, you just have to subtract 2 from that, which gives you 5.265 seconds. Plug that in, and it gives you the velocity, and then using tan theta you can get the overall the direction of it. So yes, I mean that's how this question would be solved. So yeah, thanks for tuning in.